I'd like to remind you that for more Microsoft webcasts, please be sure to visit us at microsoft.com/webcasts. Thanks again for joining us for today's MSDN presentation. Now it's my pleasure to introduce today's presenter, Michael Wong, Senior Program Manager here at Microsoft. Take it away, Michael.
Okay, thanks. Hello, hi, ladies and gentlemen. Good afternoon. This is Michael Wong. I'm a lead program manager in the relational engine of SQL Server. And, I just want to go to the next slide, basically, together with the introduction for myself and my team. Basically, my team in the relational engine specifically cover the T-SQL language support. That including, the type system of the SQL language, also, the DML, the SQL language, the DDL, metadata, T-SQL procedural programming, like store procedures, functions, transactions, all the T-SQL related programming features. My team is basically driving that, and based on the customer request and the business feedbacks, we are providing the features for customers. Other than that, we also support like the globalization, for example, in terms of Unicode support, collation support, and also the supportability features for T-SQL. For example, like error handling, exception handling, triggers, tracing, and so that's really what my team is, has been covering, for in SQL Server 2005 and also in the new SQL Server 2008. So for this presentation, I'm going to mainly cover what we have introduced for T-SQL programmability features in SQL Server 2008 release. As you can see in the slides, I'm going to majorly cover those major areas in terms of new types we added in SQL Server 2008, and also some language enhancement for the SQL language in terms of DML and DDL, and some support definitely for T-SQL procedure programming. I think there are going to be some delighters. Some of the people will definitely like to see. And also we also add some SQL CRR support on top of the 2005 SQL CRR feature. Again, there's others like globalization, also some dependency management for store procedure triggers and all those database objects you created from T-SQL. And the last one I'm going to mention is the Beyond Relational. I'm not going to specifically cover the details of Beyond Relational, but I'm going to definitely give you some overview in terms of what are those so-called Beyond Relational features we're introducing in the SQL Server 2008. So let's just get started. So here's the agenda. Basically, is a list of the features, all the main areas I list here. I'm going to just go one by one and give you some overviews. Also, as much as possible details I can about each features. Based on the time, I'm not be able to go to all the details, but I will try my best. So again, if you have any questions, just feel free to just write your question to the Q&A, and I will love to answer that. At the end, if the time allows, I will give you guys a demo, and I hope you guys will like it. So, okay, so let's get started. So the first one I'm going to introduce is the new date and time data types. So basically, in SQL Server 2008, we finally decide, we're going to introduce the new date and time based on the strong request from customer and the market, because this is one of the most wanted types as far as we can tell. So in SQL Server 2008, we're adding 4 new types. So there's the data type, which is data-only type, and the data type also has a large year range in comparing with the existing date time type. And the second one is a time-only type, and again, it has larger fractional precisions compared with the existing date time type. Also, we provide so-called user-specified optional parameter for this type. So you can specify whatever precision you want. That can be from 0, which is no precision at all, to 100 nanoseconds. So 100 nanoseconds is the largest fractional precision with support for the time type, and that's aligned with what Windows and .NET support for the time type, and it's bigger than the existing datetime type, which only have 3.3 milliseconds support. In addition to the daytime time types, we also introduced a new time zone aware type. It's called daytime offsite. So by what that means is basically this type will have 3 parts, which has the date part, the time part, and the time zone offsite part. With the value of this type will be stored in the database as in UTC. On the other hand, we also store the time zone offsite, which, for the original value, we store that as well for retrieving purpose, for reporting purpose. Again, because this is the daytime type, with the time zone offsite, it also has the larger precision support and also has optional user-specified precision parameter support as well as the time type. At the bottom, the fourth type we introduced is called daytime 2. I know that probably people will have something in mind of what's daytime 2, why it's called daytime 2. Again, I think daytime 2, just try to give you an idea, is basically an enhancement of the existing daytime type. We're not going to deprecate the existing daytime type. However, this daytime 2 type will give you large year range, large precision. However, compared with the daytime offsite type, this is not a time zone aware type. It's just an enhancement of the existing daytime type. Again, if you have any questions, just feel free to send me so I can answer that later. So this slide, as you can see, I just try to give you an idea in terms of how this type has been used. Again, for the new daytime types, we support that across the whole product line. So it's not only on the T-SQL side and also on the provider side. All the providers, the native providers, ODBC, JDBC, OLADB, as well the managed providers, ADO.NET, SQL Client, all have the full support for the 4 new types. And also like other Microsoft SQL Server products like the BI products, analysis service, reporting service, integration service, as well as the replication. They all support all the new types with the full support. So as you can see from the example here, right, we also, one thing I want to mention is except the type we support, with the regular database operations such as DML, DDL, type, whatever you can think about, we support for any kind of type. We'll support from T-SQL. Also, we extend those building functions, like the very common building functions for data and time, like date chart, date name. We all have the support for the new types. As you can see from the example, because the daytime offsite type, so we extend the data part for you to retrieving the time zone offsite portion of the daytime offset value, as well as the larger precision. As you can see, the last example is like I try to get the microsecond, which is larger than the existing datetime. So you can use date part to retrieve it. The other one we added is like a bonus feature for this type. It's basically for people to retrieve the ISO week, which is a standard ISO standard week number, which is used very common in Europe. So we also kind of add that to the date part as part of this new datetime type features. Okay, so after datetime, the other feature I want to introduce is called merge statement. Basically, this is enhancement of the current DML SQL statements. What merge statement does is you can basically use the merge. I'm going to have an example to show you how that works. You can use the merge keyword by combining all the DML statements together as in a single statement, rather than you execute them in separate statements. So basically, you can do insert, update, and delete all together in one single statement. That's definitely going to benefit your performance. Also, provide you a very flexible programming model, particularly when you do population from the source table to the target table. Because as you can see in the current either OLTP or data warehousing scenarios, there's a very common scenario. You want to sync up between your source table and the target table. How you make sure they are sync up, they are aligned. So you have to, without the merge, you have to write a list of SQL statements to perform that, or still procedural functions. However, with the merge, it's very easy for you to just do that in one single statement, and definitely increase your performance. As you can see, this is one single statement, right? Again, also the merge is a SQL standard. So in addition to align with the SQL standard, we also extend the merge statement by supporting the delete statement as well, because the standard doesn't have the support for delete. So we definitely add that extensions as well. So let's go to the next example about merge. As you can see, this example just try to give you an idea. I have two tables. One is the source table, and second is the target table. So I use the merge. All the keyword I have that in yellow. That's all the keyword for merge statement. Again, this is already a CTP4 feature, and you can check all the documentation on Book Online. And so if you look at this example, you use the merge statement. You basically try to have a predicate based on the ID of both tables. Then you use those sub-statements, one matched, one not matched, and the one source not matched, to determine what do you want to perform. You want to perform update because, well, the row on both tables different, so you want to perform an update on the target table. However, if you find the row exists in the source but not in the target, which means they are new rows, you want to do an insert. And for rows only exist in target but it's already disappear from the source, which means, well, that's becoming useless, so you have to delete that from the target table. Just give you a quick example how that works. And also you can see the output can be used together with the merge statement. We also have a $action keyword which help you if you do output $action, that will put the DML statement, the action, for example, you do update, insert, and delete, all actions will be recorded into that $action, which is the basic under the cover. It's a varchar type string for you to keep track of what you're doing for this merge statement. Okay, so the third feature I'm going to introduce today is also a very top customer request. It's called table value parameters. I think based on my understanding in terms of people doing sort of procedure or function in T-SQL, there has been a difficulty in terms of how can I pass multi-row, multi-column parameter between procedures and functions, which means how can I pass a table value parameter based, in the T-SQL. So in SQL Server 2008, we basically introduced this so-called table value parameters. So by having that, you can pass a table-based data as a parameter between the procedures, functions, and also between the client and server. And that's definitely help for most in terms of the batching parameter case, or you want to do any batching operations, or you want to pass a large value, large amount of data value between each procedure and between functions, between the client and server. Because without that, currently I know some people use temp table to do that, as a temporary solution. However, there's no way for you to pass that multi-row, multi-column value through among these different procedure and functions. again, I'm going to give you an example here. So in order for you to use table value parameter, we extend the create type DDL statement. So for you, you can create a type. It's called a table type. For example, if you look at my example, I create a type called my table type as a table, and then you specify. It's just very similar as you create a table, right? So you specify the columns, the type, and then you can create a procedure by using that type, and so you can pass that type and create a parameter on that type, and then you can use that parameter inside the procedure. Also, for any variable, you can create a variable same as the parameter on this type, and then you can perform any kind of table-based operations on this variable or parameter. For example, you can do insert, you can do update, you can do delete. It's just no difference from you operate on a table. However, this is not an actual. This is not a real table. It's a table in memory for you, specifically for you. You can use as a variable or parameter, particularly for parameter. After the table value parameter, the next feature I'm going to introduce is called the object dependency. Basically, in SQL Server 2008, we introduced some new system catalog, DMVs, and some semantics for you to really query and get the result of the dependency across all the database objects you created. For example, a table, column, so procedure, function. So you can use those, and we keep track on all the database objects you create, and then we make sure that's reflected in those system catalog and DMVs. And then later on, you can query all the dependencies when you deploy your application or when you do application management. So this is again, it's a very nice feature, as you can see from the next slide. This is 3 system catalog and DMVs we introduced for you to really figure out what's the dependency, what's the relationship among each object you try to figure out. And so in the next, in this slide, I try to give you an example. For example, when I have, I create a procedure, the procedure definitely has a reference on other either functions, either another procedures or tables. So at the bottom, I do a query on the system catalog. As you can see in the result table, I show, which is that there's a column is what's the dependency, what are the objects depend on this, what this procedure P1 depend on other object. As you can see, I have the my user-defined type, the full function, the table, the T1, the table T1, and also the procedure P2, all showed up during my query and when I queried that system catalog. Just give you an example about, in this specific case, how this is going to work. Again, there's another example, basically, to show you in terms of why I try to find out. I have the table T1. I want to find out all the database objects reference mine. So I basically query, if you look at the bottom statement, I query the DMV by giving the T1 as argument. So I got all the procedures or functions or views which reference my table T1. So again, this is also just give you an idea in terms of how this object dependency improvement works. So in addition to the new date and time types, we also give some improvements for the existing user-defined type. As you know, in SQL 2005, the user-defined type has a size limit. So it's, you cannot create any user-defined type bigger than 8 KB. And that definitely brings some limitation for when you want to create larger user-defined type, either internally for ourselves or externally for the developers and the customers. So in SQL Server 2008, we basically get rid of the limit of the 8K limit. So we increase the size of user-defined type can be as same as var binary max type, which is up to 2 gigabytes. So also, for down-level clients, which is if you have a SQL Server 2005 client or SQL Server 2000 client, you want to talk to SQL Server 2008, which people create a large user-defined type. We provide a down-level solution. Basically, we convert the large UTT to a var binary max to the down-level client, or to, as you can see, or we can convert to a image type, go back to SQL Server 2000. So again, this is not a big enhancement, but it's definitely bringing us some flexibility and without that 2K limit for the user-defined type. In addition to the user-defined type, we also, as you guys know, in SQL Server 2005, SQL CLR was one of the biggest features we introduced, which definitely bring the .NET framework and the CLR runtime into the SQL Server. So for developer, in addition to T-SQL programming, you can take advantage of the CLR common language like C# or VB+. You can use that to create your procedure functions, user aggregate, user-defined type, and call them through the SQL statement. So this is definitely a big integration between SQL and CLR. So in SQL Server 2008, based on the customer request, we have done the list of small improvements to make SQL CLR storage better. So the first one is for user-defined aggregate. Again, in 2005, we still have 8K limit, so you cannot create a user-defined aggregate beyond 8K. So we increase that limit to 2 gigabytes as well as the user-defined type. Also, in SQL Server 2005, when you define a user aggregate, you can only have a single column user-defined aggregate. You cannot have a multi-input for aggregates when you define. So we get rid of that limitation in SQL Server 2008, and now you can have multi-input aggregates. That's definitely make people have a better support in terms of create their own user-defined aggregates by taking advantage of the .NET C# and VB language features. We also provide a feature when you define your the table value function, you can specify your sort order during compile time, which means we create a new syntax. So when you create a table value functions, you can use order by to specify your sort order for your table value function. This is definitely give you a better programming flexible model. Also, it's going to make your performance better because we can reduce the duplicate sorting when the TBF has been executed. And the last one is we also provide the easy access to the .NET framework functionalities. And so in order for you to access, reach .NET framework libraries, we make this easy for you. Grouping side. So this is another DML enhancement in terms of SQL statements. So as you know, when you try to use group by to do the aggregate on SQL statement, if you want to do multi-group by, the traditional way is like, okay, you have each single statement with a single group by clause and use union all to aggregate all your results. And for that, is not the bad thing of that is, well, it's sometimes you want to group by more columns, you have to write a very long SQL statement. Also, that will bring some performance impact. So in SQL Server 2008, we introduced this so-called grouping site. So that allows you to basically group by multiple columns together and to execute that as a single statement. So that basically provides the same result set as you have done in the past by using union all and combine all the single group by statement. And also, it will make the aggregation query and the reporting definitely going to improve the performance and make your query fast. As you can see in this slide, I gave you this example, basically tell you how the syntax looks like and how this grouping site will be executed. As you can see, you used to for this statement, you used to have at least 3 or 4 statements with union all of each other in order to generate the same result. However, with the grouping site, you can basically to aggregate all the group columns together in one site and get the same result. This is definitely a better programming model to definitely shorten your statement. Also, going to improve your performance. As I can see, as I said earlier, this is a single statement rather than a union of multiple statements combined together. DDL trigger. I think in 2005, we introduced this DDL trigger support. So and people really like it, in particular for security purpose, for DBA, for supportability. So you can really put your triggers on DDL statements to monitor, to control, the action of DDL. However, in SQL Server 2005, we do have some limitations because not all the DDL, all kind of DDL operations is supported for DDL trigger. So in 2008, we get rid of that limitation. So right now, any kind of DDL operations, even including some internal stored procedures and functions we created, internally, you can create your DDL trigger on top of them as well. So it doesn't have to limit only on certain DDLs. So this is definitely a big, enhancement for people who love the DDL trigger. And also, as you can see in my slide, we also, to make sure there's no expansions of group creation, and we try to make sure the position on event group is happening for DDL trigger. We also exposing the XSD, we have add some XML support for DDL trigger. So when you create an event schema, you can basically exposing the XSD schema with XML schema definition when you create your event schema. So this is another support we added for DDL trigger. So from the T-SQL procedure programming perspective, we, in addition to some like the table value parameter, also like the object dependency, those so-called some middle size or large size features, we also, based on the strong customer demands, we introduced some new delighters, which is a small feature. However, definitely that's going to bring some easy programming ability and better developer experience in terms of T-SQL programming. So as you can see, the fourth one we introduced is you can use the insert value clause to insert multi-row rather than you have the multiple statement to insert single row by each statement. So this is again, it's a very good feature for you to operate the insert statement for multiple rows without needing multiple statements. So this is a single statement for you, and rather than you have to give a lot of statements for each single value. And performance is definitely good. Also, it's not bad in terms of programming model. The second one is we add some support for a few of this assignment operators like plus equal, minus equal, times equal, and divided equal. So this is definitely very small improvement, but it's I'm sure people doing a lot of SQL programming definitely like this, and this is definitely going to add some value for developers. And the third one is for variable initialization during detection, because we had a lot of people complain in terms of when you declare a variable in SQL Server 2005, when you want to initial the value to the variable, you have to call a separate set statement. And that's kind of, well, it's not the biggest deal, right? However, this is definitely, if we can initial the value during the declaration, why not? So that's why, we also add this small features for you guys, particularly, for people who love, develop, using T-SQL a lot. The last small features we added is basically, this is also kind of like strong request from some of the customers in terms of the building convert function for binary data value. Currently, when you try to convert a binary value to a character data, you cannot get the string in hex. What we convert to is basically we convert to the decimal value of the hex. So it's not a common conversion scenario in the real world, because people want have a binary value representing a string that has a 0x A1 B1 is in the hex value. And of course, you can make this happen by creating your own user-defined functions or procedures. However, performance, compared with the building functions have a better performance than user-defined functions for procedure. Also, it's easy to use, right? So convert function is very common. So that's why. So we add this, as a developer, and I hope you guys will feel this benefit. In addition, on the globalization area, we have a couple of major requests from the field and from customers, and the one is basically one of the biggest one is about the collation support. As you know, in SQL 2005, in SQL Server we snapshot the collation from Windows. So in SQL Server 2005, we didn't do a better job to really fully align with the Windows collation. So we have a gap between Windows collation and the SQL Server collation, and that's transparent to a problem for people develop their application, and then their application result, which is based on Windows collation, will be different from the database result if you're talking about doing comparison or indexing on the same set of result values. So in SQL Server 2008, particularly when to align with the Windows Vista, because in Windows Vista they also add a lot of new collations, and based on the cultural requirements, based on the customer requests. So in SQL Server 2008, we decide we're going to have a full alignment with Windows collations by make sure in SQL Server 2008 we are on the same page with Windows. So by doing that, we're adding all the new collations Windows added to SQL Server 2008, and also we're adding a new versions for the existing Windows collations we support in SQL Server 2005. So the new versions is going to be 100, with the collation name in mind. So when 2008 ships, you will see during the setup, you will see there's more collations added, and there's some collations with the 100 version, which represent the new collations. There is definitely, in terms of the new collations we added, there's definitely some, because there's some new sorting rules, new cultural comparison and the sorting semantic, and also we're updating some of the existing collations, but we don't we're basically adding some new support. We're not changing the existing behavior. I don't want you guys confused. We're not changing the existing correlations in terms of the sorting, the casing, all the correlation rules, but we add some enhancements based on the Windows support. So some existing correlations, you will have more powerful support in terms of correlations. So deprecation, as we are adding new features, right? So meanwhile, we're also deprecating, or we're planning to deprecating some old features. However, in SQL Server 2008, we're taking this very seriously. We want to make sure we don't want to deprecate features when people is not comfortable, or we don't want to deprecate features when people is not ready. So basically, for each deprecation features, we separate by stages. So there's basically 5 stages if we want to deprecate a feature. For example, we deprecate some correlations, or we deprecate some data types. Just give an example. So we have the 5 stages like announcement, warning, final, support, removal, and feature deprecation. So on each stage, if you are using any of the planning to deprecate features, you will get a message. Basically, we have some trip event and trigger for each features we're going to deprecate and tell you which stage you are on, and give you kind of a message so you can be aware without any surprise. And then, because we have 5 stages, so it's the time we feel is enough for you guys to really understand what feature we want to deprecate. If you really have a strong opinion against it, you can let us know before the feature has really been deprecated, so we can change our ideas. So that's basically another thing I want to mention we are doing in SQL Server 2008. So yeah, the last one I want to mention is I'm not going to spend too much time on beyond relational because this is going to be another topic, but I do want to give us some idea in terms of what we have done on those beyond relational features in terms of on the T-SQL area. So as some of you already know, we basically add some spatial support for geographic data, and for basically for both the point, line, or the plant data. As you can see, you develop GIS application. So this is going to be a big advantage. Basically, we introduce 2 data types, which is a system user-defined type. It's built based on the large UDT type we have, but it's a system type. Along with the type itself, there's a lot of functions, building methods associated with the type itself. So for GIS application vendors, for people who really develop GIS, geographic applications, or so you can definitely take advantage of this new types, so to make sure they're very easy to use and easy to program. In addition to spatial type, we also add some so-called semi-structured data support. So definitely XML. I know you guys know SQL Server 2005. XML is one of the biggest feature we added. Basically, we add the native support, the native type support for XML. And in SQL Server 2005, we keep giving the investment on XML by make sure it has the better data model and schema support. We also introduced a new type called hierarchy ID. It's specific, and hierarchy ID is basically a data type with all the building methods. It's specifically for you to programming and operate against hierarchical data inside the database. I have a later demo a chart to show you what hierarchical data looks like, what hierarchy ID. We also add the sparse column support. Basically, so for any kind of null values, when you define your column as a sparse column, the null value doesn't have to take any space. So basically, it's very efficient for storage and also for performance as well. And we are also, together with the sparse column support, we are increase the number of columns per table. So for you, you can support currently 1024. You only can create 1024 number of columns per table. So with the large column support, you can create columns beyond that. So that's also a feature, and also you can build index on those columns as well. We also introduced the so-called filter index. So when you create an index, you can do conditional index. So you can use the where clause to specify the subset of rows or the small set of rows you only want to build index on. That's going to save you storage, also increase performance. As you can see, here's a slide in terms of what hierarchical ID is about. So basically, as you can see, the hierarchy ID type is going to store the hierarchy path every node in the tree. And also, as I said, we have all the building methods for you to build the tree, to query each node, to do subtree operations, to insert the node into the tree, to remove a subtree to a different location. So any kind of tree operations, or hierarchical data operations, you can use this hierarchy ID type and with its all the building methods. This is the two benefits of this. First of all, hierarchical data is not a relational data. However, this one is going to provide you the programming model and the programming semantics, also the performance benefit in terms of how you deal with hierarchical data in a relational database. The traditional way is you use self-join, you create a child column, a parent column, and with foreign key, it's complex. You have to write a very complex self-join, or you can use CTE, common table expression, which we introduced in 2005. Again, it's also not a good programming model. So hierarchy ID is just basically this is the type, right? So you can just basically use the very common SQL statement and all those methods to operate on hierarchical data. I'm going to have another talk specific to hierarchical data. So if you guys are interested, just feel free to send me an email. I can send you the slides, and all the examples. Again, this is also a feature already shipped in CTP4. You can see all the information in book online. So sparse column I mentioned, right? So you can sparse column we introduce attributes. So when you create a column, you can use the sparse keyword and specify, make sure the column is sparse. Again, we as I mentioned, it's definitely good for storage because we're going to make no space required for null value, and also definitely have performance benefit, and you don't have to do any change in your DML statement. We take care of that under the cover for the null value for you, but it saves you a lot, particularly when you deal with the property bag scenario, or you want to have multiple tables to deal with property values for single columns. So this is again a very nice feature we're introducing in SQL Server 2008 for semi-structured data. And filter index, as I mentioned, you can basically create an index by conditionally specify your condition. So you can only create index on partial rows instead of the whole. If you have a meaning row, you only need, for example, 1,000 row, which is need to be indexed, and for your query, you don't have to create all the index for meaning rows. That saves you a lot of space and definitely increase the performance, particularly when when we have to load all the metadata and index into the cache during execution. So right now it saves a lot of memory as well, and also increase the memory assumption. So there's some restrictions also because there's a very simple limited grammar, when you use where, and again, it's only on non-cluster index. You cannot create filter index on cluster index. We're thinking about to do that probably post SQL Server 2008, but currently, you cannot do that for cluster index. So here is an example to show you how the filter index, you're going to create for filter index. As you can see, okay, you create the example I show you create an index on the zoom lens, and you want to specify only for those types equal to camera. So as you can see in the table, only those 3 rows there will be index created. And the second example is like, okay, you create a index basically on the width side, but I specify only for type equal to pants. So only those 2 rows, which is in yellow, have index created. And then you basically, you can do the regular DML operations without any statement change. There's nothing required for your programming surface. So this is, again, it's a very nice language feature, and I hope you guys like it. So yeah, now we have 10 minutes, 12 minutes. I'm going to do a quick demo to you guys. Basically, I want to give you, I have an integration demo with the date and time types, table value parameters, and merge statements. So I'm going to spend 5 minutes, and just before I finish, just hold your breath, and just wish I'm luck to get this one passed successfully. Okay, so I'm going to do that.
And Michael, just a reminder, if you haven't done so already, folks, please do select the F5 key on your keyboard,
yeah,
and you'll be able to see the demo in full screen mode.
Yeah, sorry, yeah, just make sure you type your F5 key, and so you have the full screen mode, and you can see the demo more clearly. So basically, my demo is, I just want to give a quick introduction. So my demo is, I'm going to use this new datetime types, table value parameter, and merge statement. So what I'm going to do is, I'm going to create 2 tables. One is, I call it a stock table, which has all the stocks I currently own. So the stock samples and also the stock values, and what's the last trade date I have for this stock. And the other one is called daily trades table. It's basically record all the trade activities I perform during every day, for each stock. So my goal is, I'm going to at the end of each day, I'm going to populate and synchronize my daily trade record to my stock table to make sure my stock table is keep up to date. So just give you an idea. So when I create those tables, as you can see, okay, for the last trade date of the fourth table, I use the date type because this is really about date. I don't need a time person. So that's definitely, then also I create an index on that date. And just want to make sure, I can take advantage of this new type because not only you save storage, also improve performance, and definitely you don't need a datetime type. You only need a date only type. And then for the second table, I also use this datetime offsite type because you can have a trade anywhere. You don't have to be in one location. So if you only have a datetime part, probably it's not. It's going to be ambiguous, right? Because you need the time zone offsite to tell you, and you need to have the UTC a unique value if you want to do some comparison to this trade time. So for me, so right now, okay, I'm going to create those 2 tables. I just want to make sure, because there's nothing there. Okay, let's create the 2 tables. Okay, now I passed the first one. That's good. So now I'm going to insert some values. Just as you can see, I insert, particularly for the daytime offside. As you can see, this is really the string literal I gave. Is the -08 is the time zone offside of Seattle. I just gave an example. So I put on there. Now I'm going to insert them into my table. Okay, now I do a select. I just want to show you. So now this is on my daily trades. So basically, I perform all the trades. So now I got my table filled up. And then also, if you look at, I think I just showed one. It's yeah. This my stock table is so far I have 3 stocks. It's Cisco one, Microsoft, and Google. It's under the the latest trade data and also the stock value I own. And this statement just give you an example. I do a basic. I want to specifically mention because we also extending when we're doing the daytime improvement, we make sure the convert function doesn't lose the indexability if the daytime column is indexed. So in general, when you call a function, even though the column is indexed, when you call the function like this, you will get a table scan. But as you can see, let me show you. Yeah, as you can see, this is I show you this is basically show me like as an index seek rather than a table scan because the convert function we extending that for all the new daytime types. So now when you have a daytime column which is the index, you won't lose the indexability and seekability. So this is a small enhancement. I just want to take this chance to mention to you guys. And then right now, on the next step, I'm going to create a table value parameter. As you can see, so this statement. So I'm going to create a type called my table type, and I'm going to have three columns in this table value type, and then I'm going to create a procedure. So if you look at what my procedure does is I basically pass this table value parameter, which I'm going to fill in some data into this table value. Basically, the data will from the trading table, and then I use this table value parameter and all the data inside it to basically do the merge into my stock table. So as you can see, what my merge statement is going to be, if I see, okay, if I have the same stock simple, as long as the quantity, because sometimes I probably sell, I will buy some stock. So I want to make sure if the quantity, the plus result is equal 0, which means, well, I sell them all. So I don't have to keep any stock. So I will delete a record in my stock table. And however, if I see that's not the case, which means I need to update my quantity in my stock table, because if I sell more or I buy more, I need to update. And then the third one is, well, if I purchase some new stock, which is not already in my current stock list, I need to insert that into my stock. So this is a very simple statement. I just want to show you how that. So I create this procedure. Then next, what I'm going to do is I show you this. Before I call this procedure, I show you how I first of all, as you can see, I declare a variable of this table value type. And I'm going to, after that, I'm going to insert into this variable by select record from the daily trade table. So basically, I'm doing a DML statement on this table on this table variable has no difference from I'm doing anything on a table. And then I can do select and do update. So as you can see, so right now if I execute all this statement, as you can see, I do some insert on this variable, I do a select, and then I do a update, and then I do a update again. So as you can see, if you look at, well, again, this is not about the table. This is a select statement from the table value variable. So as you can see, what I have done is, well, I have updated this Microsoft. As you can see on this current screen, I have update to Microsoft of the stock symbols, and I update that. So all the DML statement has successfully happening, right? So so this is a big advantage of, well, you can really perform any kind of table-based operations on this table value variables. Then again, what I'm going to do is, well, now I have this table value variable. I'm going to pass that to the procedure which I created earlier. As I mentioned, well, this is basically a table value parameter, right? So I'm going to pass that, and then in the procedure, it's going to execute the merge statement. Then finally, we can see what pop up in my stock table. So if I do this, okay, now I got, you can see that the rows, check because I update and delete rows basically in my stock table because of merge statement. So as you can see, well, here's the latest. One thing I want to show you is if you go back to the original when I create my daily trade table, I basically intentionally to make Cisco as 500 because I think it's Amazon. Yeah, I have Amazon there. Other table, I try to make sure I can have a case which I got a 0 stock value. So as you can see, basically that Amazon and Oracle is gone because the merge statement is happening, right? Because it's based on the condition and determine that. Also, as you can see, some of the stock value, which is the stock symbol is not existing in the target table, has been deleted because we don't need that anymore. So this is just give you a quick demo in terms of how the merge works and how the table value parameter can be used and how you pass that to the store procedure, and also how the new datetime type, some of the the new highlight features, the new datetime types. I hope you guys really like this demo. And if you want this code, send me an email. I can just forward that to you guys for future reference. And again, all these features is in the current CTP 5, and you can go ahead to try them and also find all the information from the book online. So let's go back to where we are. So after the demo, I think right now I'm probably out of time. If you have questions, I'm going to please just feel free to click the Q&A and input your question. I'm going to look at that. And here again, meanwhile, I just want to mention here's those resources. As I mentioned, in the SQL 2008 July CTP, which is CTP 4, most of the features is there. Except some of the features, but the new CTP 5, it's out of the door, so you can have those, and all the book online have all the information about new features. You can just find all of them, and with all the examples, descriptions. Feel free to send me an email if you have any specific questions after the presentation. And there's more resources in terms of MSDN, and also some blogs about the new features. It's very I see some very heavy customer activities in some of those new features and some very good feedback we want to consider, for future, or probably, if it's feasible, we can consider that for Katmai as well, for SQL Server 2008. So let me just jump to the question and to see.
Before you get over to questions, Michael, let me make sure that folks have an opportunity to fill out the survey before you log off today. What you should see now is a website from Microsoft. Click on one of the two blue links there in the middle, and that will pop up some survey questions for you to respond to. We do appreciate any feedback you might have with regards to this webcast delivered today. With that, back over to you, Michael. It looks like there are a few questions teed up for you.
Sure, yeah. So let's just go to the first one, which is from Anil, about how wide are these types. I assume I assume it's asked about. Let me see. So the new types we created for the new datetime types. Basically, the date type will take about 3 bytes in storage, and the time type, as I said, is a variable depending on the fractional second precision you specify. It's from 3 to 5. And also, then for the daytime offsite, it's the largest is 11 because the time offsite takes 2 bytes. And then if you go to the larger precision, it basically will take you or more. But if you go less precision, it's going to be small. Basically, I think if you have a date time 2 type with the millisecond as a precision, we save 1 byte compared with the existing datetime. So definitely we did some storage optimization for those new types. So let's go to the second question is from Petra. And the question is, what about LaTeX type structure or entities where a child can have multiple parents. We have a concept like that in manage our steps right now, and we are working with it, but it would be great to have a better way to handle it. This is a very good question, and I don't think I have any good answer right now. I think for semi-structured type is definitely our future. Beyond SQL 2008, we're looking for to create more either the semi-structured type or unstructured data types by using by taking advantage of our new user-defined type infrastructure. So this latency type, I think that will be something sounds like very interesting, particularly for a child has multiple parents. So I like to talk to you off the line if you want to send me some probably your current working scenario, and I like to look forward on that. Thanks. So yeah, so the next question is from Salam. It's very simple. One SQL 2008 is expected to be released. A very good question. So we are currently have the CTP5 out of the door, and we have another CTP6, and we are basically targeting the summertime of 2008 to get the SQL Server 2008 out of the door. It's definitely because it's called SQL Server 2008, so that won't be wrong. Thanks. So another question is about table value parameters. How efficient are the in-memory structures that hold the table value parameters? To answer your question, is basically we don't do anything special. Basically, the table value parameter in memory is just handled as a temp table. So we don't. Again, this is not about performance improvement. This is really specifically about programming model and providing you a better programming ability. Even though there's some occasions we can have you can have some performance increase. However, this is no big difference in terms of when you do in temp table. So it's and then the other question is, would it be better to create a temp table and index a drawing column? It's better to perform a drawing on non-index column in table. I will say when you do a temp table approach, or you perform a drawing on non-index columns, I will say I don't think the non-index column in a table value parameter is going to bring you any performance increase. But I don't think that's going to be that bad compared with the temp table index of drawing column. So again, this is from the in-memory perspective, it's no big difference in terms of temp table. Are there any new service broker features in SQL 2008? As far as I know, we didn't we didn't add any big improvement in SQL Server 2008 for server service broker. However, I think we did add some lightweight improvements. So again, you can send me an email. I can point you to the right PM, and so he can give you more specific information about all those lightweight features we add in SQL Server 2008. So the next question is now we have is from Anil again. Is hierarchy ID useful in trying to replace open schema database? I will say, the hierarchy ID is specifically targeted for when you want to deal with tree-based hierarchical data, for example, product catalog, organization employee chart, file folders, and particularly for complex hierarchical, technical hierarchical information, and you want to handle the tree-based operation. That's basically what we're target for. And whether it's going to replace, the open schema database, this is a very interesting question. Together with that latest type, to be honest, I'm not so sure. Probably, this is a good one. I like to look forward. I think definitely hierarchy ID you can use hierarchy ID semantics of open schema database, but I don't think hierarchy ID is specifically defined for that. can we create an index on table variables now? As far as I said earlier, you definitely, because this is, again, this is a user-defined type. So you can create an index on user-defined type variable. You definitely can do that. Will SQL 2008 have intelligence? Yes. As you can see, I think if you got the CTP 5, you use the Management Studio, you will see the intelligence is showing up in the Management Studio when you programming your T-SQL. It's very cool stuff. Okay, so that's all the questions. Again, if you guys have any questions, just drop me my email. So my address is mfwang@microsoft.com. Okay, so thanks folks for coming, and appreciate. Again, if there's any question because of the time I couldn't answer all of them, drop me an email, drop me a line. I will follow up. Thank you. Bye.
All right, ladies and gentlemen, that does conclude the audio portion of today's MSDN webcast. I'd like to remind everyone to please do take a moment to fill out the survey prior to exiting the session room. And with that, a special thanks to Michael Wang. Thank you all for joining us today. You may now disconnect from the audio portion of today's conference. See you next time.